Welcome to Study Loop.
For this problem, on the topic of projectile motion, we are given the initial velocity and the angle at which a ball is projected, and we are told that at the top of its motion it hits a bird in a tree. If we ignore air resistance, we want to calculate the speed at which the ball hits the bird. So if we assume two-dimensional projectile motion, we know the ball will trace the path of a parabola. Its initial velocity is 200 meters per second at an angle of 60 degrees above the horizontal. Now, we want to calculate its velocity v at its highest point h. Let's first calculate the x and y components of the initial velocity we'll call u. So the x component of the initial velocity u is equal to the magnitude of u, 200, times the cosine of 60 degrees. And this is equal to 100 meters per second. And the y component of the initial velocity uy is equal to 200 times the sine of the projectile angle 60 degrees, which gives us the y component of the initial velocity to be 173 meters per second. Now we know at the highest point, the y component of the velocity of the projectile must be 0. So Vy is equal to 0. And we know that the horizontal velocity remains constant throughout the motion since there's no force acting on the projectile in that direction. So Vx is still 100 meters per second. And therefore we can see that the resultant velocity of the ball at its highest point is simply due to its x component, which is 100 meters per second.